if it's something I can fix, I'll fix it happily. But if it's something I can't fix, when four people are getting it wrong, I'm like, well,
Just letting you know, we
I appreciate
figured
that.
out the, I don't know what the hell.
That's totally fine. Totally fine. Okay, I think we're going to test this data to see if, what do we test at the end? I forgot now. Cantilever breaks. Are cantilevers worse than V's? Or are the V's better than cantilevers?
Yeah.
Okay, so we think they are. Let's see if our guts are steering us the correct way, because we haven't measured the standard error yet, and that's kind of the point. We have to measure that as well. So I'm going to come over on the side board, and let's talk about the test statistic. Now, again, you will not be doing this every single time. You will not be constructing a test statistic manually, more than this. Focus. There we go. But it is a new-ish one. Now, JC, I like that you said that. Thank you very much. It's new-ish. It's actually just a change of what we already have, and here's why. We have to maintain Stacy's confidence, the 95%. Here are the test statistics we've seen so far. So we've seen a single proportion. For a single proportion, it looks like this. Z is p hat minus p. I'm just going to put standard error underneath if that's okay with you guys. Rather than writing out the whole function for standard error, we don't need to write it out for every single one. At least for this one anyway. So that's pretty easy to do. You have a sample proportion, a believed population proportion, and you divide by some standard error that is correct for that data set. Fair enough? Then we had one mean, or one average. It's definitely good. I heard somebody say T. Yes, it's a T-score. It's still a measure of standard deviations like Z is, but we use the T distribution for averages. So it's a T-score, and it actually has a beautiful parallel to this one. It's got a gorgeous parallel. It's x bar minus mu, which is the continuous corollary to p hat minus p, over, now you might remember this from 243, S over root n. And I did want to write that one out rather than just calling it standard error, because that's important to see, because you need to have the sample size obvious, and since we're working on t's right now. So let's see if we can take this and build a test statistic over to here. Okay? So, how about two means? What would we do with two means? What would we do with two means? Well, it's still going to be a t-score. It's going to be one t-score. The problem is, we had one x bar in the last one, yes? Say that again. Is that what we're going to do, though? What are we trying to see? What are we trying to see with respect to the stopping distances of the cantilever brakes and the V brakes? If there's a boom! If there's a difference.
So would it be XR minus?
Yes, not squared, minus, subtract. If we square them, then we get feet times feet, which is feet squared. We're not measuring area, we're measuring feet. But we're trying to see if there's a difference in the averages. So x bar 1 minus x bar 2. Yeah! Now somebody might say, wait a minute, you didn't leave any room for mu. As a matter of fact, I didn't leave room for mu1 or mu2, didn't I? Let's talk through it. Let's talk through it. If we made it look just like this, there'd be another subtraction sign right here. If it makes you feel better, imagine these in parentheses. Minus, what would then be here? Mu1 minus mu2. I mean, if you want to make an exact corollary, yes, exact corollary. But what do you think mu1 minus mu2 should be in the null hypothesis? Don't overthink this. You know the answer. Remember, you think there's a difference in the cantilever brakes, yes?
So in the null hypothesis, it would be 0.
It would be 0. There's no reason to even write it, because the assumption is this implies there's a difference, the null implies there's no difference. So it would just be minus 0. So there's really no need to even write it. There's not really even any need. Now that's different in most cases than these guys, because these guys, we had numbers from you. We had an average IQ of 100, we had a speed limit of 30, we had the majority of 50%, we had the Prevnar sick rate of whatever that was, 13 point. We had numbers, but when you have two independent data sets, I didn't know, for example, I don't know what the average stopping distance is with cantilever brakes. I didn't know what that was going into my study. I'm just trying to see if whatever that average is larger than the average stopping distance for V brakes. And that's why this is actually a more powerful test than either of these. Because there's not some superfluous number you're testing against. It's actually, you're letting the data speak for itself. JC, go ahead.
So the
Yes.
for a matched mean.
That's always going to be 0. That's this,
Yeah.
but that's 0. Always. Now the thing is, you don't actually you don't compute these manually. The machine computes them. But that difference is going to be 0. You're always seeing there is a difference. It's essentially the same difference that we're doing right now. It's how you set the data up.
So the middle one,
Mhm.
matched, and the
Yes.
one that we're doing is for independent.
Unmatched, independent. I love the words, you guys. Unmatched, independent. I love the words. Yes. You do need both. You need both. Pre-post test, left, right hand, things like that. Left, right eye, for example, trying to see if there's a difference in vision between the left and right eye. You need all that stuff. But then you also need control group studies. Say you're trying to measure drugs, we're going to look at this later on. But you're trying to see if there's a difference between a control group and an experimental group. That's generally not matched pairs because a person can't be in both groups.
Could that be like thumb versus
That would be a matched pair. Because assuming it's your thumb and your finger, they are matched.
If you were just independently, you had
Or not
500 people do thumb and then 500 different people.
That would just give you a very small standard error on the matched pair. The thing is, if you had 500 people do their thumb and then 500 different people do a finger, yeah, then you're over here.
That's what I said.
Oh, that's what you said.
I was like, how are they
Yes!
matched?
No, boom. I'm sorry, I didn't hear the other people. I heard 500 people thumb and finger.
No.
Yes, then 100% correct, Kate. 100%. Dan, go ahead.
Okay, so we're assuming it's 0 because we're assuming that the null works.
Yeah, exactly. We go in assuming this every single time. That's why it's always nice to kind of look at the convention of equals. That would mean that if mu1 equals mu2, then mathematically the difference in these two has to be 0, which is why I place 0 right there too. Fair? Good! Now, what goes there? Because that's how we actually measure significance. Did anybody do x bar on 1 minus x bar 2 already? In your 1 bar stats? Is anybody, Katie, did you already do it?
did.
You did. And is there a difference? I mean, there must be,
There was,
obviously.
yeah.
How many feet?
23.4 versus 15.32.
23.4 minus 15.32! Holy crap, that's a big difference. 8 feet of difference! But that might not mean anything. That might, statistically, as a biker, that means a hell of a lot. That's 8 feet. That means I hit the tree that's less than 8 feet away from you, or I didn't. But statistically significantly, that might be meaningless, right? If this is very large. If this itself is equal, for example, to the number 8 feet, then a difference of 8 feet divided by 8 feet is 1 standard deviation, and 1 standard deviation, as Angie's saying, is not that far from average. Thank you. Correct.
Even if it's 2.
Even if it's 2, it might not, and this is where it gets interesting too. T-distributions depend on sample sizes. So you have to make sure you deal with that, and I say you, I don't mean you, I mean technology deals with that for us. So the question is, we now know this, but we don't know this. Any theories as to what this should be? Any ideas?
There should probably be an N in there.
That's right. Yes. Matter of fact, I think there should be 2 N's in there. Why 2 N? N1 and N2. Definitely have to weight this thing for N1 and N2 for the sample size. Love it. So we gotta have that. Should be a root N, I'm guessing. What else should be in there?
Is it,
Be brave.
is it root n minus root n, or is it root n minus n?
That's the question. Which way do we do root like N1 minus N2? Is it root N1 minus root N2? There's all kinds of possibilities, right? I mean, we could have something like this. We could have something like this.
Aren't they the same?
They're not necessarily.
No, oh.
Not necessarily. If one of them is 0, they are. Well, actually, if N1 is 0, this is up to fine. But they can be the same, but they're generally not the same. What else is missing, friends? Oh God, the sample standard deviation needs to be in there too, right? I mean, we have to, and there have to be 2 of those, right? We've got to have an S1 and an S2, and they've all got to be linked together, don't they? Rather than just give you the formula right now, I want to show you, because I didn't buy this the first time I saw it, when it was told to me. I'm like, nah, I don't get that. So I went home and did an algebraic proof. And I'm like, okay, I buy it now because it's algebra. And if anybody wants an algebraic proof, what I'm about to show you with an Excel simulation, it's on.
I feel like you were the only person that would be like,
I
I don't
might-
believe that, let's go.
You know, believe it or not, I'm not. There's at least one other person who has emailed me and thanked me for the stuff I post online. It's like, I love this enrichment page. I'm like, okay, that's me and him.